recording. Okay, so we're going to be looking at problem 4.4 now. This is on page 70 in our handout. So I'm going to pull up the illustration here. This is 4.4 right here. It says, we want to determine the moment of the force about points A, B, and C. And this is a cantilever beam, meaning it's just supported all on one end. And that's where point A is. And then there's 10 feet to B and then 10 feet to C. Okay, so we're going to show the free body diagram to start off with. So I am going to, underneath my camera here, we're going to show a simplified version of, okay, this is going to be A. You don't have to worry about it being a cantilever beam. This is going to be point C. And then B is in the middle. And I think it said 10 feet, right? Yeah, 10 feet. 10 feet. And then I don't want to forget my convention with the counterclockwise moments are positive. All right, looking back over here, I've got a 1,000-pound force pulling up on B. So I'm going to draw a 1,000-pound force. Make sure you label it with units. And then we've got C out here. We got C. Notice something about C. C, we're not given the angle, but we're given the slope. Do you notice anything about that slope? What kind of a triangle is that? A 3, 4, 5 triangle. Okay, 3, 4, 5 triangle. Now, I'm not going to assume that everybody knows about 3, 4, 5 triangles, but when we see them, they become a shortcut for us. You don't have to do components. Okay, so what I'm going to do is we're going to talk about a 3, 4, 5 triangle briefly here so that you can see what's going on. So in this case right now, we've got 3 at the vertical, 4 is the horizontal, and I'm going to draw a right triangle here. Okay, right triangle. And then here is my hypotenuse. So this is going to be units of 3. I don't care if they're 3 feet, 3 inches, 3 meters, just 3. This is going to be, oopsie, 4 underneath here. Okay. And I want to find my hypotenuse. Okay, I want to find my hypotenuse. Now to do that, I've got a right triangle and I know the two sides, so I can use Pythagorean's theorem, right? So I can say my hypotenuse is equal to the square root of one of the legs squared, 3 squared, plus the other leg squared, 4 squared. Okay. So now as we look at these numbers and we square these and we add them together, what is 3 squared? 9, right? What is 4 squared? What's 16 plus 9? 25. What's the square root of 25? 5. Okay, so our hypotenuse is 5 units long. So it's a 3, 4, 5 triangle. 3, 4, 5 triangle. So as I said earlier, this becomes a shortcut for us. So down here, if I know that 3 is vertical, do you see that that would correspond to the magnitude of my vertical component? Okay, this would be my, we'll call this CY. Okay. And my horizontal components, this is going up and to the right, my horizontal component is going to go out here. And it's going to correspond and be related to the units of 4. Now notice the hypotenuse. What is my value on the hypotenuse? It's 500, right? So multiplying each one of those sides by 100, do you see how CY is going to be 300 pounds and CX is going to be 400 pounds? Okay. No components for this. You don't have to find the angle and do the cosine and the sine to come up with 300 and 400. Okay. So all we're going to do out here is we are going to draw the X and the Y component. The X is going to point to the right. Again, it has to have the same net effect as that original force. And then my Y is going to go straight up. And instead of saying CY and CX, I'm just going to simply call this 300 pounds going vertical, 400 pounds going horizontal. Done. Okay, so 3, 4, 5 triangles. When you see them, you're like, yes, I got this. No work associated with those. Easy peasies. Okay, so here's our free body diagram. And we want to find the moment about points A, B, and C. Okay, A, B, and C. So let's start by summing. So step number 2 is going to be, I'm going to sum my moment around point A is equal to. So I'm going to put my finger on A and I'm going to move to the right and I'm going to pull in the direction of my first force. It's going to cause a rotation. So that's going to be 1,000 pounds times its perpendicular distance of 10 feet. And as I rotate this, this is going to go in a counterclockwise direction. So that's positive out front. Keep my finger on A and I'm going to pull in the direction of the 300-pound force. That's also causing rotation. So 300 pounds times perpendicular distance is going to be 20 feet. Okay. If I look in the rotation, the direction of the rotation, it's going to also go counterclockwise. So we're going to go positive out front. Put my finger on A, I've got one more force, 400 pounds. It is not going to rotate. It's going to pull on the point. We don't include it. And if we pull back along its line of action, goes right through the point. Okay, so we're just going to multiply and then add and subtract. Moment around A. So it looks like that's going to be 10,000 plus 6,000. Is that 16,000? And our units are pounds times feet. And it's a positive, meaning, you know, if I put my finger on A here, based on the direction of those forces, and them being offset, this whole thing is going to want to go like this. It's going to want to go in a counterclockwise direction. Now, why would that be important to me? Why would I want to know that? Like, you might, you know, at some point you're going to be like, why do we keep doing these? You know, why am I doing this? Why am I summing moments? When we get to equilibrium, and we're going to be now supporting these in static equilibrium, they're going to help us to know what are the reactions of the supports and what direction do they have to be in. And then I'm going to design my supports to do exactly that. Okay. All right. Sum the moments around point B. So now I'm going to put my finger here. I'm going to pull on the 1,000 pounds. Does that cause a rotation? Nope. So I don't include it. Move along. I've got now 300 will cause rotation. So that's going to be 300 out front times perpendicular distance between B and C is 10 feet. And then my 400 again is gonna just pull. And then the direction of that moment is going to be positive counterclockwise. So the moment around B is going to be equal to 300 times 10, a positive 3,000 pound-feet. All right, go ahead and do C. See what you come up with for C. C. So if we put our finger on C, which two do we eliminate right away? 300 and the 400, right? Yeah, because those are just going to pull on that point. They're not going to rotate. But when I go back in this direction, the 1,000 does cause rotation. So down here, I'm going to say 1,000 pounds times perpendicular distance is 10 feet. And then as far as the direction, this is going to rotate clockwise. So this is going to have a negative out front. So here's another case where we have a positively directed going up force, right? in the Y direction, causing a negatively directed rotation. So don't assume just because a force is in the positive direction, it's going to have a positive rotation. Okay, so that's going to be a negative 10,000 pound-feet. So good. Questions? This is fun. Thursday night, 7 o'clock. What else would you want to be doing? Statics, of course. All right, let's do a review. Go ahead and fill in what you can here, and I can help fill in the blanks. So page 8 is a little bit of a review. I'll zoom in for those who maybe don't have a printer available and they need to fill in and take the notes. Paper, do you have it pulled up and you're filling it in as you go? Oh, that's cool. James, can you do that too? Nice. So let's start looking at the top here. Even if you're not completely done, we'll look at all the answers. So drawing the new convention. So the new convention is going to have the positives going to the right and up for the forces. And then we're going to have, a counterclockwise directed moment, is going to be positive as well. Fill in the blank. Get to think like I do. All the forces pointing up and to the blank are considered blank. What do you think? All the forces going up and to the right are considered positive. Shout it out. And all moments causing a blank rotation are also positive. Counterclockwise, excellent. Moments are the tendency of a blank to cause a rotation about a blank. A force, yep, force. About a point or an axis, either one. The magnitude of the moment is calculated by blank, the force times the blank distance back to the point. I'm going to change horizontal to something else. Perpendicular, yep. Multiplying by multiplying the force times the perpendicular distance. I think we've done that like 3 times now. Perpendicular. Any questions on any of those? Write the moment equation in variable form and label all the parts. So sum the moments around a point is equal to force times distance. And we're going to put a plus, a little more room here, plus minus out front. So this part right here, sum of, right? Moments. And this is going to be about a point or axis. The plus minus is going to be the direction of rotation. And then F is force, D is distance. So F, force, D, distance. Okay. Remember, this is how you have to write it in variable form. The summation symbol comes first, the capital M, and then sub whatever letter is being used for the point that you're summing around is equal to, and then in parentheses, you're going to write the force times the distance. Units. What are the units for a moment? Any. I don't care. Newtons times meters. What else? Pounds times feet. What else? Pounds times inches. Kips times feet. Anything that's force times distance, right? Units of force. Newtons, pounds, kips, kilonewtons, right? Units for distance. Inches, feet, meters, centimeters, da 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 da. All right, the last little section here. The sign out in front of the individual moment identifies the blank of rotation. Direction, yes. Not the direction of the force, right? So counterclockwise is positive or negative. Positive, and clockwise is going to be negative. What did you think of my guided notes? Are they good? I was excited. This was something that I do like once a month training for teaching. And okay, I know other people have used this before, but I never really took the time. I thought, you know what? I'm gonna try it. And it was kind of fun. I hope you guys enjoyed it. I think we're gonna stop there tonight. I think that's a good time to stop. And my main reason is this. I don't want to go too far in module 4. We've got our unit assessment coming up. And this way, if there are any lingering module 2 or module 3 assignments out there and you want to hang around and get those in, you're welcome to do so. With what we have covered today in module 4, you could do the first 2 problems. You would have what you need. So if you did want to start the homework in module 4, those first 2 would be appropriate. So that is where I'm going to stop right now. I'm going to stop the recording. And, but then if anybody wants to hang out and work, you're welcome to do so.